Welcome everybody. My name is Susanna Wilkinson, Regional Head of Emerging Tech at Herbert Smith Freehills and Chair of the Digital Commerce Committee from the BLS section. I'm joining you from Brisbane today, the lands of the Turrbal and Yagara people, and I pay my respects to elders past, present and emerging. Thank you for joining us in this first of the 5-part seminar series on AI, artificial intelligence, which is curated especially for Law Council of Australia and BLS committee members. We all recognise the transformational potential of AI. We also recognise that it brings legal risks and issues. As lawyers and committee members of the Law Council, we have a role to play in shaping the future of how we engage with AI and also how it engages with us. I think it's critical that we understand this technology and the issues properly. And judging by the number of people who have registered to attend the session, there's many of you that agree. These sessions will be recorded and made available for those who are not able to attend live. And we do intend to leave some time for Q&A at the end. So please use the Q&A feature throughout this as we go. Just by way of sort of introductory or opening remarks, this series is a collaboration. It was coordinated between the Digital Commerce Committee and the IP committees. And I'd like to thank Angus Lang and Duncan Longstaff for their efforts in pulling this together. Thanks also to the unflappable Jessica Morrow and Sally Bysouth, BLS, who always seem to get things done. I'd like to just invite Angus, Chair of the IP Committee, to make some brief remarks, and then we will get straight into our first presentation.
Thanks very much, Susanna. AI presents particular challenges for IP law and policy, and the IP Committee of the Law Council will need to grapple with these challenges in the near and medium term. And so welcome to the Intellectual Property Committee members to this seminar. Thank you for joining. Thank you also to Susanna Wilkinson and to Duncan Longstaff, who have, with infectious energy, organised this series with me, to Jessica and to Sally as well. Back to you, Susanna.
Thank you. So this seminar, the 5 sessions that we have here, really curates an A-list of industry experts who are going to share their insights. And it's my pleasure today to introduce the first of our speakers, Lee Hickin, CTO at Microsoft for ANZ, also New South Wales Government AI Advisory and Review Committee member and responsible AI lead. So Lee has 3 decades of experience, possibly longer, in IT, and has advised clients on digital transformation through many of the tech hype cycles in that time, including identity, security, cloud, IoT, and now artificial intelligence. He has an obvious passion for technology, been working with computers since the 80s. And he joined Microsoft in 2005, did a stint in Amazon in Singapore around 2015 before returning to Microsoft in 2018. Lee is passionate about the positive potential for AI to build an inclusive and a bright future. Lee, we really appreciate you taking the time to be here with us today. The floor is yours.
Thank you, Susanna. And it's slightly horrifying to think that it's just over 30 years, actually, but there you go. Life is moving quickly. Thank you for that, and thank you for the introduction. And Susanna, something you said yourself in that intro, this idea that we have to adapt to AI as much as AI is adapting to our world, is a really great way to frame this, and I'm going to refer back to that kind of concept as we talk. So thank you for making that point. So I have a conversation I want to share with you. I want to share some slides. I want to show some demos. I want to kind of get you to understand, see, feel, experience this wave that is generative AI, large language models, this new wave of AI that we find ourselves living in. And I've had the great pleasure, sometimes pain, but largely pleasure, of being the lead for Microsoft's engagement around this OpenAI collaboration and the technology that sits behind it. And so in the time I have with you, I'm going to try my best to cover what you see on the screen here. I want to talk about what is AI. Let's get ourselves grounded in some common terminology. What's different about generative AI, and really understanding the technicalities. And I'm not going to dive too deep, but I'm going to make sure we all understand what a large language model actually does. We'll look at the tokens, the prompts, the engineering, talk a bit about how we're solving that with Azure, but this isn't about me telling you what Azure does. This is really about us all getting some common knowledge around this technology. And as I said, spend some time demoing it. I think this stuff really comes to life when you see it in action, and And you can kind of see the differences in some of these things I'm sure many of you have heard about. No need to put a show of hands in Zoom. I wouldn't even know quite how to get that to see anyway, but I'm going to take a guess that many of you have played with ChatGPT, and that has been your experience and your journey into this world of generative AI. And I think we have to, in many ways, sort of acknowledge the fact that whilst GPT languages or large language models have been around for a while, that moment when ChatGPT was released on November 30th, 2022, was the moment where the world kind of woke up to this idea that generative language models are something that actually can be interacted with by anyone. And they really opened up the floodgates, sort of brought out this zeitgeist of AI being a truly human interactive tool that isn't locked away in sort of the laboratory or the research or the scientific community. So with that, let's get started with this idea of kind of what is artificial intelligence. And just to ground us in an idea, because I think it's one of these interesting terms. I sit on three or four committees and advisory boards around AI, and it's surprising how often we're discussing this idea of what do we mean by AI, because there are very many different descriptions, and then it gets even more complex if you talk about artificial general intelligence. But I quite like the simplicity of the two things here, that this artificial is not natural, but most importantly, created by humans. And that will be a recurring theme here about the importance of human ownership, of human administration, of the relationship humans have to what AI represents. And then the intelligence piece and determining what we consider to be intelligence, or often, as the Turing test was designed to develop, the perception of intelligence. If something is intelligent, if you believe it to be intelligent, is it ergo intelligent, versus whether or not it's truly defined to be an intelligent object. But we'll talk more about that as we go through the content. So as I said, this is nothing new. And in fact, as Susanna so politely pointed out that I've been doing this for a very long time, this is a screenshot from a Commodore 64, a Commodore 64 that's sitting right next to me, in fact, running something called ELIZA, which was a very early 1960s developed early stage chatbot for psychological analysis or psychoanalysis. And it's very simple, very basic, also quite terrifying in that it only took me 2 prompts. I would like to write a story. Why? Because it would make me happy. For the machine to ask me, well, do you have some psychological problems that you're trying to fix with this? And we've come a long way. I mean, this is very simple terms, but we're now in a world where you can take a picture like the one you see on the screen here. You can send that to an AI model like GPT-4 and ask the very simple question, what is funny about this image? Describe it panel by panel. You know, any child could probably tell you what the panels mean. Not everybody could probably define the humor in that image, if at all you can see the humor in that image or the absurdity of that image. But GPT-4 as a language model is able to look at the picture, and we'll define what we mean by look at, but able to look at the picture, ascertain the panels, the separations of the various pieces of the puzzle, define them as being 1, 2, and 3, and then determine what's happening in those pictures. And then on top of all of that, make a reasoned assumption on what comedy might be or what absurdity might be in that picture. Now, that in itself seems fun, an interesting meme. You might see it on Reddit or on the internet, but actually take a moment to think about what that means. This is a computer system, an AI machine that is able to see, understand what it's looking at, infer an intention on all the things it sees in that picture, and then decide what is funny or humorous about that picture. Nothing could be a more humanistic trait than the element of comedy, the fact that we can determine whether or not something is funny or not. Yet here we have an AI system that is doing exactly that. And by that virtue, Arthur C. Clarke said this in the 60s, that any sufficiently advanced technology is largely indistinguishable from magic. And that's exactly what we're seeing here. ChatGPT feels like magic. And don't get me wrong, there's a lot of magic in there. But my job today is to sort of remove the magic, but keep the wonder of what's possible. Now we understand what these things do. So with that as our sort of opening context and point, I want to go back and just kind of get us aligned on a principle around what AI used to be. Now, as a community of legal professionals, I'm sure over the last 10, 20 years, you have seen a fair share of conversations, engagements, cases that relate to the use of AI, because we've had for a long time this ability to do what we call classical machine learning based AI, where we take a data set that represents an interesting set of information. We build a model. We have scientists who build a model, a mathematical structure that looks at that data and helps us discern what that data tells us. We actually ask the model to say, look at these images of, look at these MRI images and tell us which ones look like cancer and which ones don't look like cancer. Or look at all of these school assessment reports and tell us where students have done well and students have done poorly. And in all of those concepts around machine learning, we're teaching the model, the AI, to look at the data and make decisions about it. Cluster the data, weight the data, make the data tell you what it's hiding in its information. And what we've seen is these have been heavily powerful tools, but of course they've been caught up in a number of issues, not least of which is the issue of inherent bias. If we give a machine, a model, a piece of AI, a bit of data and ask it to say, tell us what the data is telling you, it will cluster the data into groups and make decisions about it. And often those decisions are hidden, the black box problem, that the data is going, well, I see all of these applications for home loans and all of the ones that have been granted are for middle-aged men with middle incomes in their 20s to their 40s. And all the ones we've declined have been other people. Therefore, the best people to give loans to are men in their 20s to 40s, and we should never give loans to anyone else. Ergo, the bias problem we see in classical machine learning, because it only has one data set and we're asking the machine to tell us what the data tells us. That's always been the problem with historical data sets. When we look at this from a large language point of view, what changes is we're now still feeding data into the model, but the model itself has changed dramatically. The model is now built around this concept that was developed in 2017 called the transformer model, which is in simple principles, a model is designed to encode data that it's fed, and then as a result of human or otherwise interaction, decode that data into new versions of it on the outgoing. So if we give it lots and lots and lots and lots of words on the input, it's able to regenerate lots and lots and lots and lots of words on the outside. But it is not in any way learning what the words are representing in terms of the data. It's simply learning what the words are to each other, the weighting, the relationship of those words. That's the fundamental difference. And that's the piece that we need to unpack a bit. But it's why large language models are less about being a biased data set, although there are issues of bias in there that we could explore, more about being, as Susanna said up front, a new paradigm for us and how we may talk to AI, and by virtue of it, how it may now talk back to us. So let me break that down a bit into some kind of easier to consume pieces. I'll talk about GPT because it's the language model that we work with largely, Microsoft's partnership with OpenAI around the generative pre-trained transformer, or GPT-3 or GPT-4, and ChatGPT is an element of that. But there are others out there, Bard, Lambda, Llama, BERT, Palm, by Amazon, by Microsoft, by Google, by Meta, by open source. They're all largely built around the same idea, which is this transformer, that encoder and decoder I mentioned. So the first side of the technology is about this idea of being generative and pre-trained. So pre-trained means that the model has been trained with 100, well, in GPT sense, 175 billion words. It has seen and read in context 175 billion words. Now we have about 40,000 unique words in the English language. And so it's seen the same words many, many, many times, but it's seen them in different contexts, different sentences, different uses. It's seen them used together more frequently or not more frequently. It's seen statements of fact in those words, and it's seen creation of creative content, words, books, novels, fiction, and so on. It's also designed to be generative. So one of the key things of the transformer model is this idea that its job in life is to complete what you start. That's why we talk about this sort of, you see it as this idea of prompts and completions, or if you've used ChatGPT, it feels like it's answering your questions. It's not really answering your questions. It's just finishing what you started, but it recognizes when that's a question or if that's just a statement. So for example, if you were to write into any GPT language model, what is the capital of France? It will come back to you and say, the capital of France is Paris. Now that's a combination of generative, as in it's just responding to what you've said. It knows that these are the most logical next words that a human being would have written should it have been presented with the sentence, what is the capital of France? It also is inferring some pre-trained knowledge that it has seen the word France and the word Paris so many times together that it has inferred a relationship around this concept of being the capital. And that's where we'll get to the transformer piece. But additionally, because it's generative, it is capable of making up new words, making up new sentences. And this is where it becomes really powerful, because we ask it the question, tell me a story about a dog lost in space, using no more than 30 words. It is very capable of doing exactly that. Now, it's told me a story. So it's understood what a story is. It's understood what a dog is and being lost is and in space. And it's recognized the construct of 30 words, although I've never actually counted this response to see if it's 30 words. It may not be. And in the story it's given, it's come up with a dog name that's quite appropriately a space dog. It's connected the idea that a dog and an owner might have an emotional connection. And these are all ideas of what we call weighted attention. The idea that dogs and space and the story concept I'm looking for has a whole series of weighted, important constructs that the language model has then gone out into its large cloud of words, or tokens as they are referred to, and pulled out all of these words to create that. So I'll talk about how that happens in the transformer piece, because it's, in some ways, that's kind of the myth behind the magic. It really is just guessing the next word, but guessing it in a way that is deeply more complex than anything that a human being is capable of doing as we construct sentences. So I talked about something called weighting and tokens and this idea that words are connected. What you're looking at here is a Google tool called Projector, Embeddings Projector, which in simple terms is a way of showing visually how a large language model like GPT recognizes the connection of words and how they mean something to each other. And I thought this was an interesting word to use, the word dolly, because in a sense, the first thing that comes to mind when I think of a dolly is a small child's toy and the toy that they might play with. But if you look at the word cloud, and it's kind of a bit small to see there, but I'll be able to show you, or talk through it, is two things. First of all, cloning is a very close approximation to the word dolly, because Dolly the sheep was cloned. Camera is also an approximate word weighting to dolly, because cameras sit on dollies in certain scenarios. But also Willie Nelson, Johnny Cash are also related to Dolly, because Dolly Parton is a singer. And you can start to see how any one word has potentially hundreds, if not thousands, of relationships to other words. Massive clouds of words that have all these complex relationships. That complex relationship is called vectors. And we think about words having a relationship with other words. So words like eat and pizza are related because we often eat pizza. But it's more detailed than that. It's not just about how we might use them together. It's how often they appear in our language. How frequently do we say words like confabulated? Very infrequently, I suspect. How similar is that word to a food word? So in the dolly context, how similar is dolly to the word cancer? Well, there's a distant connection, because dolly, cloning, sheep cloning, genetics, cancer, there's a connection, but it's not direct. And then where do we use them in sentences? Now, if you picture that for 175 billion words, and then figure out all of the bits of data that you might need to define each time that word appears and how it's connected to other words, what you end up with is a data set that is GPT that is somewhere in the region of 500 billion pieces of data that represent our language. In fact, not just English, multiple languages, but represent the way in which our words operate. And that complexity, that detail, that richness of that model that allows us to know the word pizza in 100 million different ways that it could be used, allows us to make the leap from the fact that Teenage Mutant Ninja Turtles eat pizza. Pizza is from Napoli in Italy, and there is a different type of pizza in New York to Chicago, and all of those nuances to it. It's that complexity of it that it provides. Which, if that isn't enough for you, then you've got to think about tokens. So I mentioned this earlier, I sort of talked about tokens, but this is how the large language model thinks about our words. It doesn't look at the word pizza or walking or sleeps. It looks at the tokens that make that word up. This is actually how it constructs the responses, because tokens define actually how we use language. So when we say the word walking, walks, walked, they're all constructs of the base word, which is walk. So walk is the token, and the modifier s or ed or ing is the extra token. And so that's how we think about language as a structure. And that's how the models are pulling all of this information together to create these very rich but natural sounding responses to us, because they totally understand through multiple iterations of it how our words are generated. So we look at the transformer on the other side of that. The transformer is the piece that is the magic. It's the thing that has, we refer to it as having attention, the ability to hold attention on keywords. A better way to think about it is memory. It's the model's ability to remember what you were talking about and what's important in what you were talking about. So let me give you a sentence. The dog was enjoying its bone. Later in the day, it buried it for safekeeping. Fairly simple sentence. Anyone here on the call, any child would understand largely what's being inferred in that sentence. When you have a large language model looking at that sentence, thinking about what it might then do with that and respond to it, it's looking at the word dog and going, the dog is an important thing in this sentence. The dog is weighted heavily. It's something I need to keep my attention on because we're probably going to reuse it later on as we talk about it. And then we say it's and it, and they all refer to the dog, but they're not the same data object. They look completely different, of course, they're different words and they'll have different weightings, but they're all the same object in this sentence. So the transformer remembers that and knows what I'm talking about as I continue to talk about it, which is why when you've talked to ChatGPT in the past and you've started talking about something and then you stop referring to the thing, but you can keep saying to it, now do it like this. Now, based on what we just said, give me another version of that. It knows context. It remembers the thing you were talking about, the dog in this case. Additionally, it knows the bone is also very important in this sentence because it's another weighted object in the sentence. And it, further down the sentence, is also the bone. But it's an it, just like the other it. So it recognizes the difference between those two its. And it weights them together. It connects them and says, these two things are the same thing. I need to remember them in context. Now, when you add all that together and you think about the idea of the pre-trained model that remembers the weighting connection of words, you would know that dog and bone would be highly weighted. In that word vector cloud, dogs and bones would have a tight connection because they are referred to a lot together. But also bone and skeleton would also be weighted quite closely together because skeletons are constructed of bones. But the model would have no semantic connection between dogs and skeletons because there's a very little inference in our language that dogs and skeletons do anything together. Dogs don't eat skeletons. We don't often talk about dog skeletons. So it would never think to respond to you here in any way post that first sentence and replace the word bone with skeleton. Even though they are semantically connected, it just wouldn't do that because the transformer knows not just the weighting of what's important, but also the connection of the words that we've defined in the pre-training and how important they are to each other. Hopefully that kind of makes it simple enough to understand, but also rich enough to see how powerful and complex this is. Because to give you another layer of complexity on that, that's about a 15-word sentence that probably any of us could remember. And if I asked you tomorrow to remember that sentence, you'd probably be able to remember mostly what it was. If I asked you in a week, you'd probably forget the exact words, but you'd know it. The generative pre-trained model's capacity for memory is much greater than ours. So something like ChatGPT can remember about 2,000 tokens, which is about maybe 1,200 words. So it can remember not just that sentence, it can remember 1,200 words, and not just remember them as in, like, I remember vaguely what we talked about. It remembers them exactly, photographically, as they were said, as they related to each other, the relationships, the weighting, the purpose, the intent, the attention that needs to be held on all of it. It remembers all of that. GPT-4, the latest model, the biggest version of that, can remember 32,000 tokens at once. So about 20,000 words at once. So it can largely remember photographically a book worth of content at one time. So that's where you see these amazing situations where you can feed into these models huge amounts of information. Imagine the transcripts from a case, a legal case. Take that transcription and remember it, and then when you ask it questions about it, it's able to extract all the content, all of the relationships between content and pieces and weighted objects in that, which might be the people or the objects or the situations or the times or all that stuff that would be in the legal construct, in the conscript, the reporting. We'll be able to remember all of that, and then you can summarize it, extract information from it. And I'll show you some demos of what I mean by that in a second. That's the power of a large-scale transformer, the ability to do that we simply cannot do in our brains. And if you think that's impressive, if you think it's exciting that we can do that kind of stuff with ChatGPT, where we're heading to now is automatic GPT or auto GPTs. And you may have heard of auto GPT, baby GPT, agent GPT, and a whole raft of these interesting new tools that now enable you to chain together these language models. So you can ask one language model at the top to say, here is my task, and I want you to break it down into 5 steps and go and do all of those 5 steps, and then return back to me with the summarization or the simplification or the singular answer of all of those things. And we're starting to see this creation of very complex chained resourcing of these GPT models and tools. Now, that's just talking about language models. Of course, as many of you know, there is also image models. And these have an interestingly different perspective when it comes to the legal side of things, because there's a greater propensity and risk or consideration for IP and sort of data violations. Now, I'm sure we'll have some questions on that, but I'm going to talk more about really what they're doing and how they're doing it. So the DALL-E image creator, much like all the others, same architecture, transformer, encoder, decoder. Instead of being trained with just words, it's been trained with pictures and the words that describe those pictures. So here's a picture of an astronaut on a horse, and the words in the picture are connected so that the model is able to connect semantically the pixel colors for a horse and the pixel and the word horse, or more easily, a cat sitting on a red sofa, understanding not just what that is, as in there's a sofa, that's a red colored thing that needs to look like this, and there's a cat, but understanding context, like the cat needs to sit on top of the sofa. A cat and a sofa wouldn't be the same thing if you put the cat inside the sofa. Understanding the complexities of that level of detail is what the language models are capable of doing. So something like DALL-E does exactly that. It does this complex representation, i.e. a picture of the sun is setting. So you need to have a sun, which is a particular type of object with a set of pixel colors and a horizon and a setting scene, and it might be on water, it might be on land, and all of that richness to it. Those are sort of fairly complex but recognizable objects. And then it can also do abstract representation. So you say the same thing, but say, now make it futuristic or steampunk. And the model is able to interpret the intention of steampunk, not just as a word, but say as a color palette and a proximity of objects. It's a highly complex model that allows us to create these images, but it's exactly the same kind of model as you would have seen the language models used today. So just to think about that from a DALL-E point of view. So as I said, it's trained on images and corresponding captions. So you need to have the words and the pictures together, pulled together from open sources. The DALL-E training set uses a whole bunch of classifiers to filter out certain types of content, sexual content, violent content. And it's actually an external database. The Hate on Display symbols database is also used to remove symbols of hate or other things, swastikas and other things like that. So there's a certain amount of work that goes into that, ensuring that certain objects aren't embedded in there. And in fact, last night I was having a play with this, trying to get the system to say, hey, could you build a picture that looks like the Mona Lisa? And it said, yes, theoretically, I can build a picture like the Mona Lisa. I said, well, then, okay, then help me understand what prompts would I need to put to you so that you would build something that was almost an exact replica of the Mona Lisa. And its response back to me said, well, I can't do that because that will be replication of an existing copyright material. So I'm not going to create that for you. But if you'd like me to create something that is artistically similar, but physically different, let's do that. So there are tools and constraints inside these systems to prevent certain things from happening. But it's not perfect. And I think this is something that needs to be well understood, that however amazing these technologies are, and they frankly are quite incredible in terms of what they can deliver, both ImageWorks and language-based models are capable of hallucinating. Now, in the word sense, that means making up facts. In the image sense, that may be making up images that maybe represent words that do not correlate together. And we've seen some examples of that in the public domain. As I said, there's not really any bias directly in the language model, in that we're not teaching it to be biased. We're not teaching it to cluster things, objects, people, genders, ethnicities into certain groups. But if you ask it questions that are biased by nature, tell me about all of the worst people at paying back loans in the banking system, it will give you a biased answer because our data, the reflection of us as a human society, is probably quite biased. So we have to think about these things. But this is where Susanna's point up front is a really interesting statement, because what we're seeing now with this level of generative AI is a complete shift in the relationship between humans and artificial intelligence. Up until this point, largely speaking, we built models, we trained it with our data, and then we asked it to explicit questions about our data. Mostly speaking, those models were incapable of creating new thought around those models. They only knew how to answer that particular data set, and they were constrained by that. In the generative world, we are giving these models a broad, general set of information. They know a lot of things about a lot of different things. And then now it becomes important on us to ask questions of those models in ways that relate to good questioning. How do we ask that question? How do we ask AI to construct information for us in a way that is less damaging, less chance of hallucinations, and more aligned to what we expect the model to actually teach us? We have to learn how to talk to AI in order to get AI to work for us in the generative sense. It is no longer a data tool. It is a language tool and a communication tool, and therefore the relationship between us changes somewhat. Now, what I'd like to do now is just show you a couple of things before we talk about some of the other moving parts. So if you bear with me, I will do a quick screen switcheroo, and you'll see some things. I want to show you some different experiences that you can sort of see with these models to get a sense of how they're changing. First thing I want to show you is, you've probably heard about the coding capability, the ability for these tools to create coded objects or language, a programming language for you. Because the models since 3.5, the one GPT, chatGPT that everyone knows, up to 3.5, the models were trained with both language and code. So what that means is a model trained on language understands how words are related to each other. But as you all know, our language is extremely unstructured, fluid, and often very confusing to use even for a native speaker because of the way we reuse components of words. Whereas code and coding is very structured, syntactical, and organized in its thinking. It requires reasoning of understanding the structure. When we train the model on both of those two things, what you get with something like GPT is now the ability for the model to both know how to code, but also how to apply reasoning over code, or reasoning over language, code logic to language. And I'll show you an example of that in a second. But what I wanted to show you is this. So I got GPT-4 to create me a piece of Python code. Now, you can read here in this one, create a Python script that displays a colored square and changes that color for each key press. If you read the way I wrote it, it's pretty actually crappy writing, to be honest with you. It's not really well thought out. I just kind of kept dumping an idea on it. And then I kind of, very simple, very non-structured, non sort of logical language. I just said, I want to build an app that does almost something that is kind of nonsensical, but I kind of had I knew in my head what it would be. 3-4 lines of text. I created that. It gave me this code here. You'll have to believe me somewhat, since I'm telling you this, that I took that code, exported it into this thing called ShapePy for a bit of Python script, and I ran it with no changes whatsoever. And what I got was my code. Now, my code basically said, whenever I press a key, I need to give the focus to it. Press a key, change the color of the square. It's exactly what it's doing. When I press the space bar, I want you to change the shape to a circle and flash it incessantly until I press the space bar again. So I press space bar and it goes crazy to create a circle. And I press space bar again and we're back to square. Now, very, very basic bit of code, but simply made, quickly delivered, and then I can iterate on it. I can change that code. I can ask ChatGPT to expand it, change it, or put it into a different language. Highly powerful tool set just simply for creating programming code. Now I want to get to this idea of, I want to get this idea of how these models are evolving their understanding of lying, hallucination, the fact that they make stuff up. So I'm going to use GPT 3.5 here, the original one. I'm going to say to him, who is Lee Hickin? That's me. The one who works for Microsoft. And I'll ask it that question. I'll copy it so I don't have to keep typing it. And when I ask ChatGPT 3.5, which is the earliest version of this model that everyone's had their hands on, what I get is a super quick answer that is total and utter gibberish. I'm not any of those things. I'm not a senior cloud advocate. I'm not based in Auckland, New Zealand. I have more than 20 years now, unfortunately. There's bits of it that are logically possibly true. It has obviously connected Lee, and it's looked for any number of Lees that might work at Microsoft, and it's looked for the weighted words in that sentence are Lee Hickin and Microsoft. and it's tried to figure out a connection of all of those two things. And in between those connections, it has landed on Cloud Advocate, Auckland, New Zealand, 20 years, and all the other bits and pieces you see in there. But it's not true at all. And if I was using this to do some research on me, clearly I would be in trouble, because that is not me, and that is nothing close to what I am. If I move up to GPT-4, now we're still working with ChatGPT. So ChatGPT is, is not grounded in any up-to-date data. You all know this story that ChatGPT is still based on data trained up to a certain point in time. But if I ask GPT-4 the same question, you'll get a very different response. So the first thing you see here is that the AI model is admitting its limitations. So this is that first point when we think about alignment, this idea that the models need to align to human expectations of AI systems. In this particular case, the first thing, one of the very early rules of computing, if you look at Asimov's or Arthur C. Clarke's rules, is that the machine should identify itself as a machine and identify its limitations. So GPT-4 does that. It immediately tells you that I only know so much information, and therefore what I'm going to tell you now is based on that. And then it also tells you at the end, this is not the right place to ask this kind of question. You should really go to a platform like LinkedIn to understand who a particular person is and who they work for. So we're moving forward. We're getting to a point where these things are better at admitting their gaps, but it still answers the question. And if I keep pressing it, it could come up with more stuff and eventually might hallucinate. Now I want to show you what happens when you ask this in something like Bing. And I'm only showing you this in Bing because Bing is a really good example of when you take a large language model like GPT, but build around it a set of responsible AI mechanisms to protect those that use it from the risks of hallucination, false information, and the inability to cite source to determine where that information came from. When I asked exactly the same question of Bing, exactly the same structure, the first thing it recognizes is, like I said, it's a weighting model. It goes and looks at the weighting and says, Lee Hickin is important in this sentence and Microsoft is important. So let me go and get those two things and search for them. And it goes off to Bing and searches the internet for that. So in Bing's context, its ability to get more up-to-date information is to search the internet, which is logical given what it does. It gets that information back and then generates a response for me. Now that response that it's generated is 100% accurate. It may not be the best answer because my prompt is pretty basic and doesn't ask a lot of information. I've not asked it for job history or, current employer or anything like that. But it's come back with an answer. It's come back with a grounded answer in, here's what I'm telling you and here's where I found it. And here's the citation link that you might want to follow to go validate that. And it's correct. That is my job title. I did join in 2005. I was the IoT lead for a period of time. It's answered my question, and it's answered it correctly because what it has understood is the need to ground an answer that it doesn't know in factual validation. Now, we could argue or not whether the internet is a fully grounded, factually right service, maybe, maybe not. But in this sense of Bing, it possibly is the right place to do it. Now, I'll show you another example of this, though, where we can change that and make it actually more of a grounded answer. So this is another demo site, but this one is built around that same concept. So in fact, let me show you a picture. If I click to here, what you just saw in Bing is this. You've maybe heard us talk about Prometheus in the public. My question went to the Bing orchestrator. It figured out that I needed to go search for some information and then send it to the language model and give me an answer. We can do the same thing outside of Bing with private data sources. So in this case, this data over here, these data sources could well be court documents, court records, client case history, something of that nature. Protected, secured in an encrypted data store, in the cloud, in your Azure service, kind of protected in the way that you protect data today. But by building, instead of the Bing orchestrator, we use the cognitive search tool to actually go and look at that information to get the right answer. So instead of searching Bing, search all of our private data, get me the information that relates to the question that person's asking, and then send it to the language model to say, right, now you know what this person's really looking for, and I've given you all of the answers. You just need to tell them in a sentence, in a more natural language sentence, instead of just giving them responses. That's what we can build. And that's what we can do when we look at tools like Enterprise ChatGPT. So this idea now that, in this case, this is the sample one, so forgive me, it looks like a demo. Of course it is, but it's truly operating. if I ask this one, which is a example of a employee portal for healthcare and HR purposes. So in this case, I want to ask it a question around my health plan. What am I entitled to as an employee? So I'll ask it that question, and it's gone off to figure out how to answer it. And you'll see it's taking a little longer than maybe you're used to with ChatGPT, because this time it's actually going into a private repository. It's going into Azure Cognitive Services. It's going to search all of these PDFs and documents that represent some private corporate data, find the information that relates to the question I asked, and then give me my answer in a language that is clear and understandable for me. Think about the idea of taking an 18-page terms of service, and I'm asking it a question to say, but what am I liable for as this particular type of person? And it being able to extract out of that 18-page terms of service the specific things that are related to the question that I'm actually asking at that time. And what you get here, just like you saw in Bing, is this ability to then look at the citations. Now, because this is a demo, you can sort of see more than you possibly would see. But what you can see here is it's pulled back the citation, so the PDF page where that answer came from. But more importantly is this, the thought process. And this is the important thing to learn about how these large language models work. Many people prompt them in the way that they would prompt a Q&A bot. You know, they ask it a question and then ask it another question. But you can actually build very complex prompts into these bots. You can actually teach them what you want them to do as you're asking your question. And so in this case, it searched for the words that I asked it to search for. So it went and looked in all the corporate repositories to find the information I was looking for. It then generated a prompt that includes basically the rules of the game, like how you need to respond to these people. And then the source, where you should source that information from, which is the text from the PDF document that relates to my question. So your prompt becomes, your statement of question to the large language model becomes not just the question, but also the grounded information in which that answer needs to be in order for that to work. And in fact, what you can see here, if I show you a couple of screens, is how that may work, because prompting becomes the key to getting good information, right information out of a large language model. Prompting strategies, the way in which you frame your prompt, provide examples of what you expect the machine to do, express the expectations of your outcome, and you instruct the model to do what you want it to do, are all the things you need to do in prompting. So for example, you might be doing what we call few-shot prompting, where you want to teach the model, hey, I'm basically converting all of these words into French. So I'm going to give you 3 examples of what I think, so you know what I mean. And then as I give you the next example, you're just going to keep repeating it. And as I would write in this example, I told it that a sea otter is a loutre de mer. If I put in cheese, it's going to come back with fromage, and it's going to come back with the right one. And in this case, I've prompted it to say, hey, this is what I'm doing. Just do everything I do from here on in, do it like this. Or you can have chain of thought reasoning, where if you had a complex puzzle to solve, like the one you have on the left here, which is the faster way to get to work, and you've given it a couple of complex, mathematical structures to figure out, without telling it how to do it, the model will actually not try and solve the problem, but complete the sentence. And that completion of the sentence has no correlation to actually learning how the model or the data itself is structured. So you see the option on the right where my prompt, and everything outside of green is my prompt, the green is the response. My prompt here is to say, here's the logic of it. Here's how you work out the logic of it. Now I'm going to give you another one. Tell me how to work it out. And you'll see the model emulates and replicates your learning. So in this case, the model is taught how to do something, and from that point on, will do it in exactly the same way. It can be taught to do something in a structured way. And it goes beyond that. And when we think about mathematics, so yes, you can, when you give them a maths problem, the model isn't trying to solve the maths by default. It's just trying to figure out what number most likely would come next. But when you tell it in a single shot, here's the maths, but then you tell it, and this is that connection of coding. When you tell it to take it step by step, the coding logic in the model says, okay, step by step means break each section apart and do it piece by piece, a bit like BODMAS would be as a rule of process for how we do maths. And it does exactly that. It takes each mathematical step and generates the correct answer. And the similar kind of thing that you can see on the right. So what I'm going to leave you with now is just a couple of slides that talks about some of the use cases. And what I want to do is see with you some ideas about, if I have this powerful tool that is capable of answering anything I ask it, as long as I ask it the right question. And it's now capable of looking into not just, you know, the big public cloud of words, but actually I can point it towards a very private set of words with very specific words and language in it, and have it only extract the answer from there. What kind of things can you do? So the one you've already seen, which is I did earlier, which I showed you, code generation. You can write in English or in language, whatever language you want, the expectation of your code. And it doesn't have to be long program. It might just be, I need a small Excel macro, or I need a small piece of code to do something like this, and have it just write the code for you. Very simple, very quick, very easy. Vice versa, you can also have it look at code you already have and tell you what that code does. So I actually took the code you saw here before, which has very little kind of instructions in it. And I said, tell me what this code is actually doing. And it's given me the code back and broken it down line by line to tell me what the code is doing. So if you have any code in your organization that runs a key function that is not documented, or you want to understand how it's doing because you want to change it, debug it, you can do that operation through a large language model. You can address open-ended questioning. So these things aren't designed for doing closed questions. This isn't about saying, what is the right way to contact the police or fire service? What is the number I need to call for emergency services? Those are clear question and answer questions. But if you have an open-ended question, and I know this is a recipe catering one, but if your open-ended question was, based on the report that's just been submitted for this particular offender, or this particular affidavit that's been put in, what is the respondent saying about the particular person or the situation or the crime or the, whatever it may be. You can ask it abstract questions around a body of text, and you can explore that text, and you can explore ideas in that text that are not immediately visible to you, depending on the size of the text, simply because it's too much information to look at in its entirety. You can reason over unstructured data. So if you have that same affidavit or some other form of legal document that has lots and lots of words in it, and what you're trying to ascertain from it was, who are the people involved? What are their relationships to each other? How do they know each other? Have those relationships changed over time? You can reason over that data and have the information presented back to you in a structured format. These are all the people. This is their closest relationships. This was the last thing they did to each other. Help to unstructure that data to really see the details that's hidden in largely unstructured information. Summarization, I think most people have kind of got their head around this idea that you have a rich body of information and you can summarize down to the key points. Summarizing is actually very hard, because if you ask the wrong prompt, it will summarize the wrong points. You need to be specific in what you want it to summarize, but it's very powerful once you understand how to ask it the right questions. And the last one, which I find to be a really interesting one from a point of view of, this is often confused with this idea of creativity. Like, we would use the language model to create new words for us or create new stories for us. And it's very powerful at doing that, of course. You can use it to create stories. But what we found to be a really interesting use case is to provide counterpoints of view to a presented situation. So I'm trying poorly to connect this to the legal industry, but if a particular set of statements were provided on a case, eyewitness statements, you might ask the model to identify the discrepancies between the statements, or tell me about, or write me another point of view that combines all of these points of view and shows me where they align. Or, if you're doing something, I'm trying to think of a good reason why you do it, but I can't think of one. But if you've been presented with a basic point of view and have no arguments to either side of it, you can use counterfactual reasoning. You can ask the model to say, hey, based on this data I've been provided, provide me an entirely opposite point of view, or give me a counter statement that would argue against this being the case. Great use case. We see this a lot in boards and boards and leadership committees, where they're being presented with an idea from the business that they want to pursue, and that idea is self-fulfilling. All the guidance they've been given leads towards the outcome of, please choose this idea. Whereas you can use a tool like this to say, well, based on all this, what are we not seeing? What would we argue against this point based on what this person has submitted as a potential idea? So you can take all of that, and then you can do complex things like chaining them together. So each time you ask it a question, and then you ask it to further validate that question, and then you ask it to further infer more information from that question. It isn't always a single shot. There's multiple shots of it. And then sometimes the amount of information you want to extract is bigger than the single piece of it, the single capacity of the model to actually do. And so you can do something called prompt chunking, where you have one chunk of information goes in, you have the model summarize it, and then you take the next chunk, summarize that, and so on and so forth until you've got your 4 summaries. And then you ask it to bring those 4 summaries together and give you a single summary. So you can actually operate over much larger data sets, even though there are potentially some limitations in memory in terms of how the model will work. With that, I think I'm about 7 or 8 minutes to go, so that's probably pretty much on time. Actually, no, I will show you one more thing. One thing I wanted to show you in a couple of minutes, because I've talked a bit about some of these concepts. I think it's good to show you how this works. If I look at this this is inside of Azure. This is how you might sort of do some of this work if you were building this as an organization trying to build something with a large language model. I talked about a couple of concepts. First of all, that your prompt can contain all of the information within it, and then you ask questions about the prompt itself. So you're not asking the model to go crazily off into the internet to ask questions. So I've got my prompt here, which is actually, I've defined it as an object called the plot. And then if I say to the model, summarize this plot, which I don't need the question mark or the dot, and I'll say that, it's going to go and summarize the plot that I've given it, which is the plot to Titanic, because, you know, I'm looking for something nice and fun and complex to look through. But it gives me exactly that summarization. Now, if this had been, say, this was not the plot to Titanic, but this was an affidavit from a witness to a particular crime or some other situation, you might be asking more questions like, who are the main characters in this plot? Actually, it'll pick up my spelling mistake anyway. And it will go and tell me who are the main characters. Now, that might be, you know, who are the people involved in this witness statement. You might ask it, what are their relationships? And you'll get exactly what you expect. So you start to now see a huge amount of complex information that you as a legal professional or someone else in that world needs to understand and recognize and look for the complexities of the relationships. You can find that information very quickly. Do the relationships change over time in the plot? Of course, you know, how does the witness statement hold up over time? Are there things that change? Are there things in it that they've said once and then sort of now drifted to a different point of view? And of course, yes, it's going to tell me the different relationships. It's going to see them change. Does anyone die in the plot? And of course, we all know that some people do die, unfortunately, in the story. And of course, with that question, we have to ask the most obvious question. Why didn't Jack climb onto the wood with Rose? Because that made no sense. But of course, the logical answer is because he wanted her to survive. So you can see how you can do these things and you can build these things into tools and services. The reason I wanted to show you this, though, is because when you're building these things as a commercial enterprise platform, as opposed to using them in the, say, the ChatGPT experience, you have full control. You have access to something called temperature. Temperature defines the randomness of the answer, the floweriness of the language, the ability for the model to pick more creative ways of responding to your statement. So you can have full control of it. It's not just a one size fits all. You can choose to be very creative or just stick to the facts, restate words I've used rather than make up new words to describe them. And things like top probabilities. How many words are you going to think about as the next word? If you give it a high level of top probability, you might find that the word skeleton creeps into that as a word to describe what a dog might eat because of the long but possible connection between bone and skeleton. Whereas if you drift that down to 0, it's basically only going to pick bone because it's the only word that would relate to what a dog may eat in the broadness of our language. So I wanted to show you that so you have a sense of just what's possible when you have full control versus what you've probably all experienced today, which is 0 control, but a creative, exciting and fun tool. When you have all that control and you can point it towards discrete data and you can control some of that hallucination, that damage, that misinformation, then you start to see how these tools could actually be worked into many professions as a tool to help you do it, not to replace the function, but to create ways for individuals, professionals and others to do things faster, do things quicker. And with that, I will finish and leave the floor open to my 5 minutes of questions, as I promised to do, almost bang on time, Susanna.
Wow. Lee, thank you so much. I'm not often lost for words, but there was so much information in there and incredible insight. So we do have a few minutes for questions. If anyone on the line would like to put a question into the Q&A, please do so now. And I might just throw to Angus, who has a couple of questions. But Lee, that was absolutely incredible to see the ins and outs and the inner workings of those systems. And I've got so many points that I've definitely taken on board for next time. And I might have to arrange a separate discussion with you. Lots of questions, but no Angus, to you.
Thanks also from me, Lee. That was an incredible amount of information and also work that went into that. So thank you for that. I'm going to give you three questions I have from an IP perspective. Just I know we don't have much time left, so you can choose as to how much you or which ones of them you answer. But these are the ones that I'm particularly interested in. Firstly, you mentioned collaboration. So Microsoft collaborating, for example, with OpenAI in relation to ChatGPT. I'm interested in particular in the question of investment in AI. So what are the parts of AI development and implementation that require substantial investment? Who are the players engaged in that investment? That's the first question. Second question is in relation to the inputs to the AI process, for example, training using data. How important is it from your perspective? It's not a lawyer's perspective, but from your perspective, if you have one, that you have IP clearance for the material used for inputs to AI. And then on the output side is my third question. So how important is it either for Microsoft or for perhaps its clients to have IP protection in what AI generates? So examples we've given are perhaps Microsoft might develop something, I don't know, for a law firm, and the law firm uses it to create valuable summaries of very large amounts of transcript or affidavits and produces a summary, which presumably someone would want to protect from copying in an unauthorized way. Is that something you've experienced in practice? Those are the three questions.
All right, thank you. No, great questions. I'm going to start with the tail end because it's easier for me to remember where we finished rather than where we started. So look, and it's probably the first thing I need to say is to be very clear. Yes, we're in a collaboration with OpenAI, and OpenAI are the ones that own, train, build, develop, and kind of create these models, these tools that we're talking about. And so when it comes to that question of, what goes into the model and what comes out of the model, that's not something that Microsoft necessarily has any official or legal position on. It's something that we would ask of OpenAI to validate. But I think, to your middle question around sort of the importance of it and the impact of it and how do we think about it, no question at all that Microsoft's deeply concerned about, the issue of IP and how we help make sure our customers remain able to use these tools in a safe and secure way. IP law, as I'm teaching you all to suck eggs here, is a complex issue right now in Australia, and particularly with the concept of AI and generative AI. It sort of is probably our best described as an unresolved conversation. But I think, from our point of view, what we see is a need for these tools to be used in ways that are safe and harm-free for society. And that's bigger than just IP. That's actually more about, the creation of harmful content, whether it be an IP violation or not, is probably our biggest center of gravity in terms of these things. The tools themselves sort of have protections in place to remove as much as possible of that IP conflict. But, there is absolutely a question that needs to be asked and a conversation that needs to be continued to have around how is information sourced for large language model training, and then how is that information then represented on the back end, as you say, in the outputs as content. For me personally, I see a very much a clear point here that not from an IP violation legal point of view, but the creation of new information out of these models is valid in the sense that I see it as intellectual property, whether it's the property of the person that programmed the prompt to get the model to do it, or whether you want to assign any kind of ownership to the model itself. I think that's a whole different metaphysical challenge. But I think, look, it's a critically important piece that conversations do go on. an official point of view from us on the tools that we provide. So we provide tools in our Bing Image Creator in particular, which is probably the one that is most relevant here. We assert no ownership over the IP that is created. So from a Microsoft's point of view, we're not in any way creating a position where we would assert ownership on our customers of IP they generate with our tool. But that's beyond that. I think, that's probably all we can and should say on the IP legal side of things, and leave it to much more learned people like yourself to figure out how our law should be modeled around such things.
Thank you.
Yes, the Mona Lisa is long. I've seen some of the questions come through. The Mona Lisa is long out of copyright, but I think general perception in society would state that it's still illegal to copy it. And you wouldn't want to buy a fake copy of the Mona Lisa being carried out as the real one if I was to create it. But it's a good point. Are universities using generative AI? I can't talk about specifics, but the answer to your question is yes, they are. Not just universities, but broadly, quite a number of education establishments are using it. For use cases, like what I'm finding most scenarios is it's largely in a controlled environment before we go wild to the broader population. In a university sense, that will be the student population. So thinking about how do faculty use it to get access to better tools to sort of assimilate knowledge and capture information. I'm not suggesting necessarily building coursework and rubrics, but in the assistance of creation of coursework and rubrics, yes, universities are using it because it's a very powerful tool.
Anecdotally on that, some of the junior lawyers at our firm who are often in the law libraries are saying that there's at least, half the students in the library at any one time are on ChatGPT.
Look, and I think that's a whole long conversation about perspectives on it. For me personally, and I've got kids in school and 17-year-olds who are dealing with the top end of school, I'm more worried that they're not learning about these things, and I am worried about them being told not to use them. I think that's an interesting challenge. How do you stop the controls stopping you do things that are perfectly legal? Interesting question, Richard. Interesting challenge. We had a very same conversation with one of our SEALA teams from our legal side of things, a lady called Courtney, on just where do the circles of regulation exist? Like, do we build a model and make it completely unsafe and allow customers to build their boundaries of safety? Or do we put safety in it and say that's the baseline that we want these models to have in society, and everything beyond that, you can't get beyond it because we just think society has deemed this to be unsafe? Terrorist material, child sexploitation material, sexually abhorrent material. I think we probably all agree that that's something we don't want these models to perpetuate. But when it's pornography, is that illegal? No, it's perfectly legal. So how do we help these models balance between that? That's an interesting, I don't have an answer to you, but I think it's an interesting statement of question to explore. Copilot advertisers, now on how do you think that is? I obviously can't give you the answer. If I knew the answer, I couldn't give you. And if I didn't know the answer, I wouldn't be able to give you the answer. Soon as I hope, because you're not the first person to ask, I get asked pretty much daily. We hope to expand it very soon. So the plan is to expand that footprint of our preview that we're running right now in the middle of this year, calendar year, but I can't give an exact date because I don't know. Does Microsoft retain copies of the stimulus instead in the A program? Good question, Mark. In long-term principle, no, we do not. And we do not store it or use it to retrain the model in any way. So we don't look at your prompts and completions as stimulus, as you refer to it, and retrain any models with it. However, what we do by default, unless we have an agreement to not do it, is as you send prompts to the model and as the model creates the completion, the answer, those two things are stored for 30 days in an encrypted storage in the sort of system for purposes of content moderation, for exactly the point we just raised. If somebody in your organization or you are using this model to experiment around something that is abhorrent material or illegal material, terrorism, creation of that kind of stuff, we have a duty of care, in fact, a legal obligation to capture that and prevent it. And so we have that model there. But largely speaking, we don't store it or keep it for any other purposes other than legal obligations like that. Are the inputs distinct, or does one person's use it from that? No. Okay, there's a bit of a confusion there because the question's around whether or not, if I put information into it, does then later on when Susanna uses the model, does my information in some way help her have a better response? In the broad internet-based model, what you get with OpenAI when you go for free in ChatGPT, I think largely I have to give you the answer, which is yes, because there is a single model that we're all playing against, and it's kind of a shared collaborative tool, to requote the oft quoted. If you're getting something for free, you're probably the product, and that's the case in that scenario. If you're doing this through an Azure interface, through a paid interface, through our service, in your private tenant, on your private bit of a network, in your private service for us, then no, there's absolutely no bleed between customers. Your usage of the model is only your usage and nothing bleeds between the two, or three or four.
Lee, we are already 5 minutes over. I'm going to ask you one more super quick question and then we will have to let our audience go. What are you most excited or worried about in relation to the direction of travel of AI from where you sit? I mean, you have incredibly unique perspective on how this is all working. Are you excited or worried? Or a bit of both?
I'm excited. I'm a tech optimist. I love technology, and sometimes I may be blind or blinkered to the risks. So I don't want to discount that. I'm worried that we collectively are focused on the wrong thing broadly, which is we're trying to regulate AI as a technology. We're not trying to regulate the outcomes of AI in society. And I think that's where our attention needs to go. And I see a lot of noise and naysayers and just agitators that are just talking about AI is bad. We should all stop AI. And I think that's a terrible outcome, because this is probably one of the most, revolutionary, evolutionary changes that humanity has brought to bear, based on, the old adage of the steam engine and the invention of digitization. This is the next one. And I'm sure lots of people said we shouldn't have built steam engines because it would destroy the horse trade. But yet here we are in a better place than we ever were. So let's hope we carry on that way. Fantastic.
Look, at 7 minutes past, I just want to thank you again so much for sharing your insights and expertise with us. Incredibly informative. Certainly I learned a lot, and hopefully everybody else on the call and those who will watch the recording afterwards. So thank you again for joining us, and thanks everyone for dialing in.
Thank you.